All right, welcome to Mechanical Weathering. We're going to be discussing your assignment for the Mechanical Weathering Exploration. So make sure that you fill these out and that you submit them on Teams. Let's get started with the first page. Obviously, the very first question is, what is erosion? So hopefully from your notes, you can answer that. It has to do with the taking away of rock that has already been weathered. Let's see. Next one, what are the three main forces of erosion? Explain each. Okay, so remember that those are wind, water, and ice. Okay, and so you can explain each of those. Just know that those three are the ones that we're looking for there. Number three, why are volcanoes not considered to be an eroding force? Remember when we talked about volcanoes, volcanoes actually add more rock to the landscape than erode away. So it's not an eroding force because it actually adds rock rather than taking away weathered rock. Okay, what is weathering? Remember that weathering is the breakdown of rock. Okay, breakdown of rock, whether that's physical or chemical, both of them are considered weathering. Okay, and then finally the difference between erosion and weathering, which is one of the main things that you'll need to know for this unit test, is that erosion is the carrying away of rock that has already been weathered. Okay, so weathering is the physical or chemical breakdown. Erosion is the carrying away. So make sure that you have those. All right, so for this next part, okay, again, I ask for a sketch. If you guys could try to make a sketch on your own piece of paper and just upload a picture of, you don't have to do a separate picture for every sketch, but do like all your sketches on one piece of paper and then just upload that with this Word document. That would be awesome. Okay, but let's talk about the descriptions. So if I go back to my simulation, okay, I'm just going to read through this real quick. So here's frost wedging. Okay, water expands when it freezes. We already talked about that. An ice cube is about 9% larger than the volume of the water before it froze. It doesn't seem like much, but the expansion of water when it freezes is one of the most effective processes of mechanical weathering. Click on the red thermometer at the left to watch frost wedging in action. Okay, so what we do is, this water basically gets into these cracks, and when it freezes, remember that it expands, and it's going to break the rock away as it expands. Okay, so when the temperature drops below freezing, the upper surface of the water freezes first. Because of its contact with the air, then the water continues to freeze from the top of the crack downward. The ice cannot expand upward because the surface is already frozen solid, so the ice has to exert its force outward as onto the rock as it grows. Each freezing may wedge the fraction open just a tiny amount, so it takes many cycles of freezing and thawing with water filling the fracture each time to break off a piece of rock. So frost wedging is a process that is most effective in cold, wet climates in which there are many opportunities for freeze-thaw cycles with water present. High altitudes are particularly prone to such temperature changes. Large piles of broken rock fragments called talus commonly accumulate at the foot of the mountain from the action of frost wedging. Practical application: don't put a can of soda into the freezer to cool it down because expansion of the frozen drink in the closed can and may create an explosion, which I hope you all know by now. Make sure you don't freeze your soda pops in a freezer because that is not going to be good for anybody. Okay, so that is frost wedging. And again, this has to do with the fact that the density of water, okay, it becomes less dense as it freezes because it expands. All right, so moving on, what is the next one? The next one is exfoliation. So if I go back, I go to exfoliation. Exfoliation is a term that describes peeling of layers. For example, your skin peels away by exfoliation. In our purposes, exfoliation creates sheets of rock peeling off of a bare rock face. In the picture at the left, slabs of the rock are breaking loose and sliding off the bare rock surface of this eroding mountain face. Exfoliation of this sort tends to create a stepped appearance to the rock face where successive slabs of rock have broken off. So basically this is just rock just eroding away. Okay, so basically the precipitation is hitting this rock and it just breaks it apart. Okay, and that's all you really need to know for this one. I'm not going to read through fracturing. Exfoliation is really common on intrusive igneous rocks such as granite. Granite forms by slowly cooling crystallization of magma. Okay, you don't really need to know most of this other stuff. Let me see if there's any other. Yeah, and that's really all you guys really need to know is that when water comes down, okay, it's going to start cracking the rock, and once it becomes cracked enough, then pieces are just going to fall down from that place. All right, moving on to the next one, we have thermal expansion and contraction. Okay, so next, thermal expansion and contraction. Crystals of rock also expand and contract as they heat and cool, like we talked about. Although the amount of expansion is slight in environments in which temperature extremes are common, however, this expansion and contraction can loosen grains of a rock enough to cause weathering. Okay, guys, this is especially common in Colorado because we have such drastic temperature changes, especially during this time, during the month of March. I mean, we had snow one day and then it was 60 the next day. Okay, those rapid temperature increases and decreases is why we have a lot of like concrete sidewalks that become really cracked. Okay, so they cool and then they heat up and they expand, and that causes these cracks to occur. So if we see this simulation here, we see these warming up and cooling. I'm actually not sure how long it's going to take for this thing to actually break off, but eventually it does break off. Let me make sure there's anything else that you need to know. Oh, it's starting to crack a little bit. Okay, and you can kind of tell in this picture a little bit that if you can accompany this, okay, the thermal expansion, with frost wedging, so if you imagine if we have this heating and cooling going on, and then we get some rain into these cracks, and then overnight it freezes, okay, it's just going to speed up this weathering process even more. Okay, so make sure, so weathering, mechanical weathering by thermal expansion and contraction is all about the repeated heating and cooling cycles slowly breaking down the grains in the minerals. All right, easy enough. Moving on to crystal growth. Hey, so here we have crystal growth. Salt crystals growing in rock fractures or in the small pores between sedimentary grains can cause rocks to loosen and break up. Usually this happens when salty water gets into the rocks and later evaporates. Later evaporation of the water produces crystallization in the pore fracture space. Crystal growth works in similar fashions to frost wedging by pushing the grains apart. Okay, so very similar to frost wedging, but this has to do with instead of water freezing and unfreezing, it has to do with the presence of salt in the water that actually form crystals once the water evaporates. So we'll see what this looks like. So you can see the seawater is going down, okay, and these are what we are calling the salt crystals, and it's going to break these rocks up so that they are able to get broken up. Okay, so practical application. If you live in cold, snowy climates, be careful how much ice salt. Okay, so if you've ever Let's see. So at my old school at Mountain View, we had stairs on the back of our school that never saw sunlight. So in the winter, our staff used to put a bunch of salt on those walkways so that people didn't slip and fall, obviously, because they would never get sun, so it'd always be icy. But the problem was we put so much salt on there that once the water evaporated, the salt itself was eating away at the concrete steps. And eventually we had to completely replace the steps because the concrete was simply just cracking and falling away. Okay, so that happens a lot in places like Minnesota that have a lot of snow, and that sort of thing. Okay, so because salt is one of the main things we put on ice to make sure that it melts. All right, next one. Oh, wrong one. We have tree roots. Okay, tree roots. This one is pretty self-explanatory, but if you imagine as trees grow, okay, their roots also grow. So another wedging phenomenon is caused by tree roots. Tree root tips are tiny and penetrate easily into the fine fractures of rocks. As the roots grow in diameter, they put stress on the rocks and can cause fractures to expand. Roots of large trees can be several inches in diameter. As they grow to this size, they can cause significant separations in rock fractures. During storms, trees that get blown down can actually yank chunks of the ground or chunks of rock out of the ground attached to tree roots. Okay, so for example, this tree keeps growing, its roots are going to keep growing, and it breaks the rocks apart, and it doesn't really stop just because the rock is there. Okay, and that's all you really need to know. In terms of climate, this weathering mechanism can occur anywhere that sufficient precipitation exists to sustain tree growth and rocks are exposed near the surface. Tree root wedging can also occur invisibly beneath a thin layer of soil, so it may be happening and we may not even be able to see it. But yeah, so that is the tree roots mechanical weathering. Okay, on to the last one, and that is abrasion. Okay, so let's take a look at abrasion. Okay, so mechanical weathering of abrasion. Abrasion is simply the mechanism of rocks breaking or wearing down by the direct actions of other rocks. So the rocks falling down the cliff at the left is undergoing abrasion as it tumbles down and breaks into even smaller pieces. Okay, so abrasion is more so rocks on rocks, okay, rather than other things on rocks. Okay, so nearly all types of sediment transportation provide opportunities for abrasion to take place, gradually rounding and wearing down larger particles and making sand and silt grains in the process. So this one pretty much sums it up. Abrasion occurs wherever sediments are transported by water, wind, or ice. During transport, rock fragments collide and abrade with each other. Okay, so if you imagine a river carrying rock, it collides with the rock that's on the bottom and can break that up, and so it's carrying even more rocks and that sort of thing. Can I replay this? I don't even know. Let me do something real quick. Okay, so you see these rocks falling, and then they break into bigger pieces because they ran into other rocks and that sort of thing. That's all abrasion is. Okay, so that, I believe, concludes all the ones we were going to talk about. Okay, but either way, you should be done with the mechanical weathering. Make sure that you upload those pictures along with this Word document to Teams, and we will be